Remember the film The Day After Tomorrow? It's a gripping tale that captivated audiences with its dramatic portrayal of a world in chaos. It depicted a world thrown into chaos by a sudden shutdown of the Gulf Stream, leading to catastrophic weather events and a new ice age. While the movie's timeline was wildly accelerated for dramatic effect, the underlying premise, that a collapse of this crucial ocean current would have catastrophic consequences, is grounded in real science. Scientists have long studied the Gulf Stream and its impact on our climate. The Gulf Stream, a powerful current in the Atlantic Ocean, plays a vital role in regulating global climate patterns. It transports warm water from the tropics to the North Atlantic, influencing weather systems and temperatures across continents. Its potential collapse, driven by climate change, is a very real concern that has scientists deeply worried. The melting of polar ice caps and the influx of fresh water into the ocean could disrupt this delicate balance. Unlike the movie's overnight freeze, the real-world consequences of a Gulf Stream collapse would unfold gradually over years and decades. This slow but steady change would have profound effects on our environment. However, the cumulative impact on our planet would be no less devastating. We would see more frequent and severe natural disasters, altered weather patterns, and significant changes to our ecosystems. Rising sea levels, extreme weather events, and shifts in agricultural productivity would reshape societies and ecosystems across the globe. Coastal cities would face increased flooding, and agricultural regions could become less productive, threatening food security. Understanding the science behind this potential catastrophe is the first step towards averting it. By studying climate models and conducting research, scientists aim to predict and mitigate the impacts of such changes. The Gulf Stream is part of a larger system called the Atlantic Meridional Overturning Circulation, or AMOC. This vast and complex system is essential for maintaining the balance of our planet's climate. This system acts like a giant conveyor belt, transporting warm water from the tropics northward and cold water southward. It is a continuous and dynamic process that ensures the distribution of heat and nutrients across the Atlantic Ocean. Warm, salty water flows from the tropics northward along the surface of the Atlantic. This journey is driven by the differences in water temperature and salinity, which create variations in water density. As it reaches the North Atlantic, it cools, becomes denser, and sinks to the deep ocean. This process is known as deep water formation and is a critical component of the AMOC. This sinking water then flows southward, eventually rising again in the tropics, completing the loop. This cycle is vital for the redistribution of heat and the regulation of global climate patterns. This continuous circulation of ocean water plays a critical role in regulating Earth's climate. It affects weather patterns, sea levels, and even the distribution of marine life. The northward flow of warm water via the Gulf Stream helps moderate temperatures in Western Europe, making its winters milder than they would otherwise be. Without this warming effect, the region would experience much harsher winter conditions. The AMOC also influences rainfall patterns, fisheries, and hurricane intensity. Changes in this system can lead to significant shifts in weather and climate, impacting ecosystems and human activities. In essence, it's a crucial component of the Earth's climate system, and its disruption would have far-reaching consequences. Understanding and monitoring the AMOC is essential for predicting future climate changes and preparing for their impacts. Recent scientific studies have shown that the AMOC is weakening, potentially due to climate change. As global temperatures rise, melting glaciers and increased rainfall are adding vast amounts of fresh water to the North Atlantic. This influx of fresh water is decreasing the salinity and density of the surface water, making it less likely to sink. This weakening of the AMOC's overturning process, the sinking of dense water in the North Atlantic, is a major cause for concern. While scientists are still debating the exact timeline and magnitude of a potential collapse, the evidence suggests that the AMOC is already weaker than it has been in over 1,000 years. Continued warming could push it past a tipping point, triggering a cascade of effects that would reshape our planet's climate. Europe, particularly Western Europe, would be significantly impacted by a collapse of the Gulf Stream. The warm water that currently moderates its climate would no longer reach its shores, leading to colder winters and potentially cooler summers. Countries like England, France, and Germany, accustomed to relatively mild climates, could experience much harsher winters, with increased snowfall and freezing temperatures. The agricultural sector would face significant challenges as growing seasons shorten and crop yields decline. Coastal regions would grapple with rising sea levels and increased storm surges. The economic and social consequences of such drastic climate shifts would be profound, potentially leading to large-scale migration and political instability. Section 5. Across the Pond, a Chilled Britain. The United Kingdom, an island nation heavily influenced by the Atlantic Ocean, would be particularly vulnerable. Its current climate, characterized by relatively mild winters and cool, wet summers, is heavily dependent on the moderating influence of the Gulf Stream. A collapse of this warm current would expose the UK to the full force of the cold North Atlantic air masses. Winters would become significantly colder, with prolonged periods of freezing temperatures, heavy snowfall, and icy conditions. Summers would likely be cooler and wetter, with reduced sunshine hours. The UK's agricultural industry, already facing challenges from climate change, would be severely impacted. Coastal erosion and flooding would become more frequent and severe, threatening coastal communities and infrastructure. The UK's energy demands would increase as heating requirements rise, putting a strain on energy grids. Section 6. Beyond the Atlantic. Impacts on the U.S. While the most direct impacts of a Gulf Stream collapse would be felt in Europe, the consequences would be felt globally, including in the United States. Shifts in ocean currents and atmospheric circulation patterns could disrupt rainfall patterns, leading to more intense droughts in some regions and increased flooding in others. The U.S. East Coast, already grappling with sea level rise, could experience accelerated coastal erosion and more frequent and severe hurricanes. Changes in ocean temperatures could also disrupt marine ecosystems, impacting fisheries and marine life. The economic and social consequences of these changes would be significant, affecting agriculture, infrastructure, and human health. The interconnectedness of the global climate system means that a disruption in one part of the world can have ripple effects that are felt far and wide. Section 7. A World in Flux, Global Repercussions. The collapse of the Gulf Stream wouldn't just be a regional crisis. It would be a global event with far-reaching consequences. This vital ocean current plays a crucial role in regulating the climate, not just in the North Atlantic, but across the entire planet. The interconnectedness of the Earth's climate system means that changes in one part of the world can trigger a cascade of effects elsewhere. For instance, a disruption in the Gulf Stream could alter weather patterns, affecting everything from monsoon rains in Asia to hurricane activity in the Atlantic. Shifts in ocean currents and atmospheric circulation patterns could disrupt rainfall patterns globally, leading to more frequent and severe droughts in some regions. This would not only impact water availability, but also the health of ecosystems and biodiversity, and increased flooding in others. Coastal cities and low-lying areas would be particularly vulnerable, facing the dual threats of rising sea levels and more intense storm surges. These changes in precipitation would have profound impacts on agriculture, potentially leading to food shortages and price spikes. Farmers would struggle to adapt to the new conditions, and the global food supply chain could be severely disrupted. The displacement of people due to rising sea levels, extreme weather events, and resource scarcity could create a wave of climate refugees, straining resources, and exacerbating political tensions. Countries would need to cooperate more than ever to manage these challenges and provide humanitarian aid. The collapse of the Gulf Stream would be a stark reminder of the interconnectedness of our planet and the global consequences of human-induced climate change. It underscores the urgent need for international collaboration to mitigate these effects and protect our shared future. Section 8. Navigating Uncertainty. The need for action. While there is still some scientific uncertainty about the exact timing and magnitude of a potential Gulf Stream collapse, the potential consequences are too great to ignore. The evidence suggests that the AMOC is weakening and continued warming could push it past a tipping point, triggering rapid and irreversible changes to our planet's climate system. In the face of this uncertainty, one thing is clear. We must act urgently to reduce greenhouse gas emissions and mitigate the impacts of climate change. Delaying action only increases the risks and makes it more likely that we will cross dangerous thresholds, potentially triggering catastrophic and irreversible changes to our planet. Section 9. Averting Disaster. climate action as our greatest hope. The potential collapse of the Gulf Stream is a stark reminder of the interconnectedness of our planet and the profound consequences of human-induced climate change. While the future is uncertain, we have the power to shape it through our actions. By transitioning to a low-carbon economy, investing in renewable energy sources, and implementing sustainable practices, we can mitigate the risks of a Gulf Stream collapse and create a more sustainable and resilient future for all. The challenge before us is immense, but so too is our capacity for innovation and collective action. The time to act is now, before the consequences of inaction become irreversible. The fate of our planet and the well-being of future generations depend